Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 11 students and the topic of discussion is limits and derivatives. In this video, we'll be focusing on NCERT solutions for exercise number 1, which is dealing with limits. In the first problem, we need to evaluate the limit x tending towards 3x plus 3. So what are the steps for solving limits problem? As we have seen in the previous video, the first step is to put x equal to 3 into the function. Function is x plus 3. If we get a real value, then we stop and get the final answer. In case we are not getting the value of limit as some real numbers, for example 0 by 0 or 1 by 0, then we try to factorize or use some other methods which we will discuss. So let us first put x equal to 3 in this function. So this will be 3 plus 3, which is 6. So we get a real number. We stop here. So the solution for limit x tending towards 3, x plus 3 is 6. Let us take another simple problem. Limit r tending towards 1, pi r square. So we substitute r equal to 1 in this function, which is pi r square. So we put pi into 1 square, which is pi. We get a real number, so we stop. So limit r tending towards 1, pi r square is pi. In this problem, limit x tending towards minus 1 x power 10 plus x power 5 plus 1 divided by x minus 1. So how do we proceed? We first put x equal to minus 1 in this function. So it will be minus 1 power 10 plus minus 1 power 5 plus 1. X is minus 1 minus 1. So we solve this and get as minus half. So this is the value of this limit extending towards minus 1. This f of x is minus half. Limit x tending towards 0, x plus 1 power 5 minus 1 by x. Let us put x equal to 0 in this function. So this will be 0 plus 1 power 5 minus 1 divided by 0. This is 1 power 5, which is 1. 1 minus 1, 0 by 0. So we are getting the solution for this as 0 by 0. So we need to go further. We haven't got the answer yet. So how do we proceed? So first step is to put x plus 1 equal to 5, x plus 1 equal to y, and then change the limit from x to y. We'll see how it is to be done. So we put y equal to x plus 1. So x will be y minus 1. We substitute here. Wherever x is there, we put y minus 1. X plus 1 is y. So, and we need to change the value of limit also, because limit is from x tending towards 0. When we have put x plus 1 equal to y and made changes to this equation as y power 5 minus 1 by y minus 1, we need to change limit also. We cannot put x tending towards 0 when the function is in y. So we need to put limit in terms of y. How do we do it? So x tending towards 0 was the original problem. So in this, y equal to x plus 1. So we put x equal to 0. So y will be equal to 1. So when x tending towards 0, y will be tending towards 1. That's what we have put. So we get the modified limit equation as limit y tending towards 1, y power 5 minus 1 by y minus 1. So how do we proceed? We have a standard solution for this. We know that limit x tending towards a x power n minus cn by x minus a equal to n minus 1. So comparing limit y tending towards this, we need to evaluate this. So we see n is 5, a is 1. We put it into this. So we get 5 into 1, 5 power minus 1. So 5 into 1 power 4, which is 5. So the final answer is limit x tending towards 0, x plus 1 power 5 minus 1 by x is equal to 5. This is the final answer. Let us solve another problem. Limit extending towards 2, 3x square minus x minus 10 by x square minus 4. So the first step is to put x equal to 2 in these expressions. Let us put 3 into 2 square minus 2 minus 10, 2 square minus 4. When we solve numerator and denominator, we get 0 by 0. So again it is coming in 0 by 0 form. So we haven't got the answer and we need to proceed further. So how do we proceed further? We try to factorize this numerator and denominator and try to cancel common factors. Let us see whether it is possible. So we put 3x square minus x minus 10. How to factorize? We know first we multiply 3 and minus 10, we get minus 30. So we have to distribute minus x as that the sum is minus x and the product is minus 30. So the combination is 5x minus 6x. 5 into minus 6 is minus 30 and 5 minus 6 is minus 1. So this is the breakup of this equation. Minus x can be broken as plus 5x minus 6. Now we can take common factors. So this 3x plus 5 we can take common. So x will be outside. Similarly 3x plus 5 will be here and minus 2 will be outside. X square minus 4 can be written as x square minus 2 square, which is a square minus b square. So this can be written as x minus 2 into x plus 2. Similarly, numerator will be x minus 2 into 3x plus 5. So we see that x minus 2 term is getting cancelled. So 3x plus 5 by x plus 2. Now we substitute x equal to 2 again in this expression, which is the simplified expression. So we put 3 into 2 plus 5, 2 plus 2. So this is 11 by 4 is the final answer. In this problem, limit z tending towards 1, z power 1 by 3 minus 1, z power 1 by 6 minus 1, we need to solve. Let us put z equal to 1 in this. So this will be 1 power 1 by 3 minus 1, 1 power 1 by 6 minus 1. So 1 power, this will be 1. 1 minus 1 is 0. Similarly, denominator will be 1 as 0. So it is in 0 by 0 form and we can write it as like this. Now we know that limit z 1 by 3 minus 1 by z 1 power 6 minus 1 is in the form limit a by b, which can be written as limit a divided by limit b. That's what we have done. We have put numerator as on this side divided by limit again with the denominator term. Now we want to put in the form which we have seen earlier. In this type of form we need to put so that we can get answer directly using the formula. But how do we do it? It is not in that form. So we divide each numerator. This is the numerator term, this is the denominator term. So both term we can divide it by z minus 1. Because limit is z tending towards 1, so we divide by z minus 1 on both sides. So we get like this, these two expression by this. Now this is coming in the standard form. Which is the standard form is this limit extending towards a x power n minus a n by x minus a is n a n minus 1. So this is in the standard form. So numerator will be this. When we put n a n minus 1, n will be 1 by 3, a is 1. So this will be 1 by 3 into 1, 1 by 3 minus 1, which is 1 by 3. Similarly, denominator term will be this, which is 1 by 6. So this divided by this will be the final answer, which is 1 by 3 into 6 by 1, which is equal to 2. So the final answer is 2. In this problem, we need to solve limit extending towards 0 sin ax by bx. Now, as soon as such terms are coming, we should immediately remember this formula. Limit extending towards 0 sin x by x equal to 1. This we know. Important thing is limit extending towards 0. If it is some other term like x tending towards 1, we cannot use this formula. So this is important. So we see that this is limit extending towards 0 sin x. If it was ax, we could have immediately got answer as 1. But the denominator term is bx. So what we do, we want ax here. So we multiply both by ax and ax in numerator and denominator. That's what we are doing here. Ax will be taken sin x by x and balance term will be x by bx. X will get cancelled. This will be a by b, which is a constant, so it can be taken outside the limit. So this will be a by b into limit extending towards 0 sin x by x. But this term is 1. So answer will be a by b. This expression, limit extending towards pi sin pi minus x by pi into pi minus x. You may be wondering, can we take 1 over pi outside, which is a constant, and sin pi minus x by pi minus x, we equate it to 1. But that is not possible because here limit is extending towards pi. So we need to make this 2 extending towards 0 and see whether this can happen. So let us put, how do we proceed? We put pi minus x equal to y. So y equal to pi minus x. So when x is tending towards pi, we put x equal to pi here. So y will become 0. So can we say when x tending towards pi, y will be tending towards 0. How do we get? Let us repeat again. First we put y equal to pi minus x. Y equal to pi minus x. And when x tending towards pi, we put x equal to pi here. Y will be tending towards 0. This pi minus pi will be 0. So we put sin y and this will be pi y. And limit also will be y tending towards 0. Whenever we are making a substitution, the limit also should change in that variable. This is important. Now it has come in the standard form where pi can be taken out 1 by pi. And limit y tending towards 0 sin y by y is 1. So this term is 1. We know by formula this is 1 by pi. So the answer is 1 by pi. In this problem we need to find limit extending towards f of x, where f of x equal to x square minus 1, x less than or equal to 1, and f of x is minus x square minus 1 when x is greater than 1. So the limit will exist when the left hand limit and the right hand limit are equal. So we left hand limit means when we are going below 1. So we are slightly, our values of x is less than 1. X tending towards 1 plus means when the values are just greater than 1. So what happens when x is less than 1? We will use this expression x square minus 1. In the limit, when it is plus 1, we use this expression. Okay, so we need to find limit extending towards 1 minus f of x. So we use put x square minus 1. When we have to put h tending towards 0, we change this limit from x tending towards 1 minus to h tending towards 0, and wherever x is there we put as 1 minus h. And then put h equal to 0. So this will be 1 minus h the whole square minus 1. When h is 0, this will be 1 square minus 1, which is 0. This is the left hand limit. Let us see right hand limit. So when x is just greater than 1, we use this expression minus x square minus 1. Now wherever x is there, we put it as 1 plus h square and put h tending towards 0 as the limit. So wherever h is there, x is there, we put as 1 plus h the whole square. So when h is going to 0, this will become minus 1 square minus 1, which is minus 2. We observe that the left hand limit and right hand limit are not equal. So the limit x tending towards 1 f of x does not exist. This is important. Suppose f of x is equal to a plus bx when x is less than 1, equal to 1 when f of x equal to 4 when x equal to 1, and f of x is b minus x when x greater than 1. And if limit x tending towards f of x equal to f of 1, what are the possible values of a and b? So we need to find a and b. So first, what is f of 1? This is given. F of 1 is the value of this function at x equal to 1. At x equal to 1, the value of function is 4. So we get limit x tending towards 1, f of x is 4. That's what we have written, left hand limit equal to right hand limit equal to f of 1 equal to 4. Now let us put this value, 4 value in this. So we try to solve now left hand limit. Left hand limit will be limit x tending towards 1 minus f of x, h tending towards 0, f of 1 minus h. So when we are going from less than 1, we use this expression a plus bx, and wherever x is there we put it as 1 minus h. So we put limit h tending towards 0, a plus b into 1 minus h. Because we are just going below 1. So it will be 1 minus h where h is tending towards 0. Now putting h equal to 0 will be a plus b. Similarly, if you are going from the higher value of 1, that is x greater than 1, so we write it as limit x tending towards 1 plus f of x, limit h tending towards 0, f of 1 plus h. So wherever x is there, we substitute as 1 plus h and then put h equal to 0. So solving this, we get b minus a. But limit, left hand limit and right hand limit is equal to 4. So a plus b will be 4 and b minus a will be 4. That's what we have written here. Now adding these two, a term will get cancelled, 2b will be 8, so b will be 4. Putting back here b equal to 4, a will become 0. So a equal to 0 and b equal to 4 is the final answer. Friends, with this we conclude this video. Please like and subscribe my channel. Thank you very much, friends.